Now for the more realistic case. This case happens when an unknown population standard deviation. Typically, if you don't know the population, how are you going to know the standard deviation of the population? This is much more realistic. So we call this, instead of a normal distribution, we call it a student distribution. Why student? Well, it had to do with the person who worked at Guinness Brewery that actually came up with this distribution. What happens here is, because we're using a sample, there's going to be more variation. The curve is going to be a little bit more spread out. And again, that's due to knowing the sample standard deviation, not the population standard deviation. The population is going to be a little bit more spread out. What's neat about it, it is still bell-shaped. That hasn't changed. So it still looks like a normal distribution somewhat. It's similar. And what happens as n increases, recall what n is. N is the sample size. As n increases, the curve starts to approach normal. As n increases, the curve approaches, gets very close to the normal distribution. Now the problem with this, we can't use a normal distribution curve because then the areas would not be the same. So there is a table on page 668 that shows you that distribution. So let's go ahead and look at that table. I kind of made a copy out of your book. You can see that it's somewhat normal. The difference on this table is it measures the area to the right. Why don't they keep it standard? Well, they went to the area to the right. So anytime you're looking at tables, you want to make sure you understand what area that table is giving you. There's degrees of freedom. Degrees of freedom, kind of in a nutshell, just means that if I have 5 people and I know their average age, 4 of them could give me anything they wanted, but the 5th couldn't vary because we know what the end result had to be. And so the degrees of freedom is going to be n minus 1. All it is take the size of the sample and minus 1. So if my sample size was 5, my degrees of freedom would be 4. We'll need that for the table. Again, you do not know the standard deviation of the population. So what are the steps for this? Well, they're almost the same. The null, if you recall, is no difference. It's going to contain the equal sign. The alternative is going to have 3 choices, to the right, to the left, or two-sided, depending on what it is I'm trying to check for. The second step is the same. It still must say that the population is normally distributed, or that the sample size is greater than 30. Remember, a normal distribution on the population is what we need for using the table when we have sample means. What's different about this? Remember, I don't know the standard deviation of the population, so I can't use the Z formula. We're going to have to use the T formula. If you recall, the Z formula looks almost identical to the T, the student. What's the difference? What standard deviation do I know? If I know the sample, I use S. If I know the population, I use sigma. Formulas are the same. It's the number of steps I am away from center. But the difference is S and sigma are not representing the same. One comes from a sample, one comes from the population. The fourth step, calculate the degrees of freedom. Again, sample size minus 1. Then we're going to use the table. And we're going to either find the area to the right, which would be what the table gives me. I could find the area to the left by subtracting from 1, as I've done before. And when I have this two-sided, you've got to remember to double that value because you have areas on the right and on the left. And when we're done, we compare alpha to this p-value to make a decision. So technically, there's really no difference other than you're using the sample standard deviation. The process is all the same, but your value for the area or probability that that would occur comes from the student distribution table, not the normal distribution table. So the next lecture, we'll be looking at some examples.